Hi friends, this is Abhishek. Today I'm discussing about Linux kernel development. So let us discuss about what we will learn in this video. Introduction to Linux kernel development. Linux kernel development process key aspects. Kernel process code organization. Kernel APIs and kernel AVIs. So let's first move on to introduction about Linux kernel development. Linux kernel development refers to the continuous process of designing, improving, and maintaining the core component of the Linux operating system, known as the Linux kernel. The kernel serves as the bridge between the hardware and the software layers of a computer system, managing hardware resources, providing a system services, and enabling communication between the hardware and the software applications. The Linux kernel is an option open source project, which means that it is developed collaboratively by a large community of contributors worldwide. Linus Torvalds, the original creator of Linux, remains the project's principal maintainer, responsible for managing the kernel's development and release process. However, thousands of developers, both volunteers and those who employed by various organizations, actively contribute to the kernel's evolution. Next, we move on to the development process involves in several key aspects. So let us discuss what we will learn in these key aspects. Version control, mailing lists, patch review, subsystems and maintainers, development cycles, testing and quality assurance, backporting. So let us discuss about what is version control. The Linux kernel is managed using a distributed version control system called Git. The primary repository of the kernel is hosted on kernel.org, and the developers submit changes in the form of patches or pull requests to be reviewed and eventually integrated to the mainline codebase. Next, we move on to mailing lists. Communication within the Linux kernel development community mainly takes place through public mailing lists. Developers discuss design decisions, purpose changes, and review code through these lists. The most critical mailing list is Linux kernel, where most discussions about kernel development occur. So let's move on to patch review. When a developer submits a patch or pull a request, it undergoes a thorough review process. Other experienced developers review the code for correctness, efficiency, adherence to code standards, and compatibility with the existing parts of the kernel, subsystems, and maintainers. The Linux kernel is a large and complex piece of software. To manage the development efficiently, it is divided into various subsystems, each handled by one or more maintainers. These maintainers are responsible for the code in their specific area and act as gatekeepers for patches related to that system. Next, development cycles. The Linux kernel follows a time-based release model. These are typically several release candidates, which are called as RC, before a stable version is released. New features are usually merged during a specific merge window at the beginning of each development cycle. During the rest of the cycle, only bug fixes are allowed and the focus shifts to ensuring stability, testing, and quality assurance. Linux is developed to be highly reliable and robust. Extensive testing, including regressive testing, performance testing, and stress testing, is performed to ensure that changes do not introduce new issues or degrade the kernel's performance. Next, we move on to backporting. As the kernel is a crucial component of many Linux distributions, some bug fixes and improvements are ported to older versions to ensure that users of long-term transport versions receive necessary updates even if they don't use the latest kernel. So these are about the key aspects of the Linux kernel development. Next, move on to kernel source code organization. The Linux kernel source code organization into several directories, each containing specific components of the kernel. Some important directories include ARCH. It contains architecture-specific code for CPU architectures. Example: x86, or ARM ARM, and PowerPC. Drivers. Some include devices drivers for various hardware components like graphics card and network interfaces, storage devices, etc. FS deals with the file system supported by Linux, such as extension for BTRFS and XFS, etc. Manages memory management related code. Next, net contains network related protocols and drivers. Kernel includes core kernel mod code such as process scheduling, synchronization mechanism, system calls, etc. So let us move on to kernel APIs. What is API? API means application programming interfaces. The Linux kernel provides a set of APIs that allows users space applications to interact with the kernel. These APIs define how user programs can access various kernel functionalities. It is crucial to maintain backward compatibility for these APIs to ensure that user space applications continue to work across different kernel versions. Changing the APIs might break existing applications and require significant adjustment. So this is about kernel APIs. So let's move on to kernel ABIs. ABI stands for Application Binary Interfaces. The kernel provides an ABI which specifies the low-level binary interface between the user space applications and the kernel. The ABI dictates how data structures are laid out in memory, system call numbers, and the other low-level details. Like the API, maintaining compatibility with the ABI is crucial for ensuring that existing software continues to function correctly. So let us discuss about what we will learn in this video. What we learned about this video. Overall, Linux kernel development is a highly collaborative and iterative process that involves many skilled developers working together to create and maintain one of the most essential components of the Linux operating system. The combination of its open source nature, rigorous review process, and dedicated community has contributed to the success and widespread adoption of Linux in various computing environments. Thank you for watching this video.